Space weather. What does this branch of physics bring to mind? One might think of the sun, the rain, snow, or even thunder and lightning. But of course, the weather we experience on Earth can't exist in the vacuum of space. For weather to exist as we see it, an atmosphere is needed, where changes in temperature, pressure, and other characteristics can change over time. This describes weather, something which defines conditions in the atmosphere that depend on time. Remove the atmosphere and insert space, and we now have a definition for space weather. But space is extremely big. Let's just consider the region of space in closest proximity to our planet, near Earth space. And there we have it. Space weather defines the time-dependent conditions in near Earth space. But questions remain. What are these conditions? And how do they change with time? Well, like the weather on planet Earth, space weather is highly influenced by the sun. The sun has an actively changing composition and a very complex magnetic field. This results in regions of strong magnetic activity across the solar surface. As these regions interact with each other, solar eruptions such as solar flares and coronal mass ejections can occur. These can often pose a hazard to human activities if their effects reach Earth. This may happen during geomagnetic storms where the expulsion of solar energetic particles from solar eruptions can affect communication systems, leading to radio blackouts or both ground and space-based satellite system failures. They are also a major concern to astronauts, who risk severe radiation sickness if exposed to these fast-moving particles. Luckily, a lot of the harmful effects are mitigated by the protective magnetic bubble around Earth. This is called the magnetosphere and serves to deflect most of the solar energetic particles expelled from the sun. However, human spaceflight beyond the protection of the magnetosphere must consider the impact of these particles, such as for future missions to Mars. Space weather is an ever-growing field in solar physics, and its research is extremely important for our lives both on and off planet Earth.